All right, hello, welcome back. We are covering 4.4 linear inequalities in two variables. Okay, so take notes. Make sure that you are keeping up with the homework. And if you need the closed captioning, the button is down below with the letters CC. Okay, 4.4, take notes. Linear inequalities. In two variables. All right, so let's just kind of recall equations before we start with inequalities. Okay, so here's an equation, right? X plus y equals 5. And we know a bunch of different solutions, right? And we know that the graph represents all the points, all the xy points that are solutions to this equation. So that when we graph this, I'm not even going to make a table or anything. We can see here some possible solutions. Like I can see that 0 plus 5. So 0, 5 is a solution. 0, 1, 2, 3, 4, 5 is a solution. I can see 1 plus 4. 1, 1, 2, 3, 4. I can see 3 plus 2. 3 plus 2, so 3, 2. 1, 2, 3. 3, 2 is a solution. I can see 4 plus 1. 4 plus 1 is a solution. 4, 1. So 4, 1 is a solution. And I can see 8 and negative 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 8, negative 3 is a solution. And we already know that when we graph this equation, we get a line. And the line is really made up of a bunch of points, a bunch of xy points that satisfy this equation. And we can see that here because we have 0 plus 5 is here, 1 plus 4 is here, and this was 3 plus 2. This is 4 and 1, and this is 8 and negative 3. Okay, so we see that the line represents the solutions to this equation. So the line is where this side equals this side. Okay, so what we're looking at now in this section is not just where are they equal, but now we are looking at inequalities. So we might have something like this. X plus y is less than or equal to 5. Not just equal, but also anything that satisfies this where this side is less than 5 will also be part of the solution. Okay, so we already know that when we graph the equation, right? 1, 2, 3, 4, 5, 5, 0, 1, and 4. We already know those are solutions, right, to this. We already know that anything that falls on this line is an x and y value that add up to equal 5. But we want to know which x and y values here make it less than 5, because those points are also part of the solution. Okay, so we're going to look at, well, how do we find those? We know that these guys make it equal to 5. So where are the points that make it less than 5? Okay, so before we get into it, let's look at some general things about graphing inequalities. So graphing in general. So when you're graphing an inequality, you're going to graph this line, okay? But there's always going to be more to it. Graphing the line means you're only graphing an equation. When you have an inequality, you'll be graphing the line and then some more, okay? Because remember, the line only tells us where it equals 5. We also want to know where it's less than 5. Okay, so you're going to graph the line as usual. Graph the line. And you're going to use one of these. You'll graph a solid line or you'll graph a dashed line. Okay, so the solid line, you'll use this if you have the less than equal or the greater than equal symbol. But you'll have the dashed line, this one, if you have the strict inequality. So strictly less than 5 or greater than 5. Because remember, the line is where it equals 5. So if we want less than 5, that's sort of going to be our boundary, but it's not going to be included as part of our solution. Okay. And then once you graph that line, whether it's solid or dashed, it's going to break it up into two sides, right? Like you have this line and it breaks it up to this side, like below the line, and then you also have this side, the other side of the line, like above the line, okay? So what you're going to do next after you graph your line, solid or dashed, is you are going to choose a checkpoint. And this is going to be any point you get to choose, but it cannot be on the line. I would choose something away from the line that's clearly away, just in case you graphed it a little crooked. You don't want to choose any point that's near the line because maybe it's supposed to be above it, but you graphed it kind of crooked, so now it falls below it, okay? So pick a point that's away from the line. And what you're going to do is check using the original inequality, the original problem. Okay? And the point that you choose as your checkpoint will either work, like when you plug it in, you get a true statement, or when you plug it in, you get a false statement. Okay? So if true, you're going to shade point side, the side that your point came from. If you get false, then you're going to shade the other side. Because remember, there are two sides of the line, right? Right? So here, if you have this line, you have two sides. This side of the line, and then you have this side of the line, right? And let's say you pick a point, wherever you pick it away from the line. So let's say you picked this point. Clearly, this point is below the line, right? It's on this side of the line. So if you pick this point and you plug it in and it works, you get a number that's less than or equal to 5, then you would shade this side that the point comes from. If you get a number that's more than 5, then you would have to shade the other side. Where's the other side? Over here. Okay, so we'll do an example so that it makes a little more sense. Okay, so let's take a look at this one. All right, let's go ahead and graph 2x minus y strictly greater than 3. Okay, that means we're going to be using a dashed line because this is strictly greater than 3. All right, so I'm going to go ahead and make a table. I'm going to choose 0 for x, right? Plug it in for x. 2 times 0 minus y. I'm going to use equals because I'm trying to find the y value that goes with it. Negative y equals 3, so y equals to negative 3. Okay, so we have that. Now I'm going to choose 0 for y. Plug that in. 2x minus 0 equals 3. 2x equals 3. X equals 3 halves, which is 1.5. Okay. All right, so I use the, here when I'm solving for my points, I'm using the equation because I'm trying to find the line. I'm trying to graph the line, and the line is where it's equal to 3, right? Okay. All right. This here, because it's greater than, remember, if you have this, then you could be solid. But if you have this, it has to be dashed. Okay. All right. So let's go ahead and graph that. All right. 0, negative 3. 1, 2, 3. 1.5, 0. And it's going to be a dashed line. So don't rush to draw this line. You have to kind of wait and make sure every step is done correctly. Dashed line, okay, because it's strict inequality, greater than. Greater than equal, you can be solid. Strict inequality, you have to be a dashed line, okay? All right, so now we choose a point. We have these two sides. You see the two sides, right? This line breaks up the space into two sides, okay? So you get to choose a checkpoint from either side. It doesn't matter. You only have to pick one point, and it doesn't matter which side you choose it from. You just need to know where it is. Okay, so away from the line, just in case it's crooked. Now, 0, 0 is always nice because who doesn't love working with, doing calculations with 0, right? So I'm going to choose this as my checkpoint, okay? Here, I'm going to put it in red. Well, I'll use purple, actually. Okay, so we haven't used purple. This is my checkpoint. Clearly, it's on this side of the line, not on this side, right? So it's on this side of the line, and I'm choosing 0, 0 as my checkpoint. So now I take my checkpoint and I plug it into here, 0 and 0. Okay, so I'm going to do my check here. Plug 0 in for x, 0 in for y, and I check to see what I get. 0 minus 0 is greater than 3. 0 is greater than 3. Is 0 greater than 3? No. Good. This is false. So 0 is not larger than 3. This is false. Okay. So since this point, which comes from this side, produced a false result, then we have to shade on this side. Okay. It's kind of like this point is a representative for this entire side. If this point fails, the whole side fails. Okay. Which means this side must be right. Okay. Let's take a look at another example. Let me back up. So you see how we chose this point? Again, you could have chosen any point. Another good point to choose right here, 0, 1 is a good point, right? You can choose any point on either side. You could have chosen, let's see, 1, 2, 3, 4, 5. You could have chosen 5, 0, right? That's away from the line. And if you plugged in 5, 0, you would have gotten a true statement. It would have worked, okay? All right, let's do another example here. Let's go ahead and graph x plus y less than or equal to 0. Okay, so I'm going to choose 0 for x. Okay, 0 plus y equals 0, y equals to 0. I got 0 for y, so I can't choose 0 for y since it's already chosen. So I'm going to choose something else. Let's see. Let me choose 1 for y. Okay, you can't choose 0 because it's already used. Okay, 1 for y. So x plus 1 equals 0, x equals -1. All right, so let's go ahead and graph our line here. Because it's less than equal to 0, we're going to use a solid line. So again, if it's less than equal, solid, strict inequality, dashed. Okay, all right, so let's go ahead and graph this. 0, 0, -1, 1. Okay, solid. Make sure you know it's solid. Don't just draw solid every time. Okay. All right. So I can't choose 0, 0 because that's on the line. Okay. So another point that's good to pick. This one's good right here. 1, 1 is good. Even 2, 2, 0 is good. Okay. Any of those are good. I would avoid fractions, decimals, negative numbers. Okay, so I would try to choose the easiest one. 1, 0 is this one's okay, but again, I want to try to be away from the line in case I graphed it crooked. All right, so I'm going to choose this point right here. Okay, I'll make it purple again. So I'm going to choose this point right here, which is the point 1, 1. Okay, and again, clearly the point that I'm choosing is on this side of the line. If I plug it in and it works, then it works for everyone on this side. If I plug it in and it does not work, then it fails for everybody here and I shade the other side. Okay, all right, so let's have a look. Let's check. So plugging 1, 1 into the original inequality, this one right here. Plugging 1 plus 1 is less than or equal to 0. 2 is less than or equal to 0. That is false. Okay, so again, we got false. So this side doesn't work. Therefore, this side must work. One of the two sides always works. Okay. All right. All right. So hopefully you are getting the picture here. Let's do another one. I'm going to have you try this. Okay, so graph this one. You try it. Hit the pause button and see if you can do this one, and then come back and check to see if you get the same thing I do. All right, go ahead, hit the pause button. All right, I'm going to choose 0 for x. 3 times 0 plus 2y equals -4. 2y equals -4. Y equals -2. All right, 0 for y. 3x plus 2 times 0 equals -4. 3x equals -4. X equals -4 thirds, which is the same as -1 and 1/3. Okay. This is greater than equal, so I will have a solid line. Zero, -2. -1 and a third. 0. Okay. Solid line, we said, because it is greater than or equal. See how it's kind of crooked? So that's why you want to choose a point that's away from the line. Okay. 0, 0 is pretty away. So I'm going to use 0, 0 again. Okay. Let me put it in purple. 0, 0 is good. 1, 1 is good. Here, let's do 1, 1. Okay. So let's choose 1, 1. Okay. So I'm going to check. Plugging that into the original inequality. 3 times 1 plus 2 times 1. Is that going to give me something that's greater than or equal to -4? Let's check. 3 plus 2. Uh-oh. 3, 4, 5, greater than or equal to -4. 5 is greater than or equal to -4. That's true. 5 is greater than -4. All right. So if it's true for this point, it's true for this side. Okay. So we shade this side. Okay. All right. Good job if you got that one right. Okay, one more example. Let's do those special case lines. Okay, so this here, if you have to graph one of those special case lines, the vertical line or the horizontal, so like this one. So remember, this is one where all the x values are the same, right? 3. So 1, 2, 3. So it's this one is the vertical. This is the vertical line. And since this is a strict inequality, it won't be a solid vertical line at 3. It's going to be the dashed. Okay. And then this should make sense. X is less than 3. So think of the number line. X is less than 3. That's this way. So that is, you don't even need to do checkpoints or anything. It makes sense. This is your X number line, and all the X values that are less than 3 are over here on this side. Okay. All right. So that is it. If you have any questions, make sure you email me, make sure you text message me, or post the question in the discussion section of Canvas. All right. It's nighttime here, so if it's nighttime over there, have a good night.